Hello, this is Joel Overton, and what I'd like to do in this video is to walk you through the process to create a group frequency distribution from raw data. Now, inside Blackboard, you'll see that I've added this YouTube video playlist titled Statistics Week 3. Attached to that is an Excel spreadsheet that contains a copy of the problem that I'll be using for this example. If you are not going to be using Excel, then I'd still recommend watching this video playlist because I'll also be talking about how to create like histograms using your graphing calculators. Now, if you open up that spreadsheet, what you'll see is the example that I'm going to be using, radiation in baby teeth. So it says, listed below are amounts of strontium-90 in millibecquerels in a simple random sample of baby teeth obtained from Pennsylvania residents born after 1979. And this is based on the study from an unexpected rise of strontium-90 in U.S. deciduous teeth in the 1990s by Mangano et al., Science of the Total Environment. Construct a frequency distribution with 8 classes. Begin with a lower class limit of 110 and use a class width of 10. Cite a reason why such data are important. Now, for this problem, they're giving you how many classes to use, 8. They're also telling you where to start your lower class limits with 110. And they also give you the class width to use. In the included video within Blackboard that comes with your textbook that I've referenced, they go in further about how do I know how many classes to use and how do I know where to start my class limits and how do I come up with this class width, and I'd recommend you watch that video as well. But for here, we're just going to use the information they give us and construct that group frequency distribution. So I'm going to open up this pad from which I can start creating a group frequency distribution, and what I'm going to need to do is to create a table for my group frequency distribution with columns and rows. And the columns I'm going to use are the following. I'm going to use a pen here, and here we go. We need a column for classes, and specifically for my class limits. And I'm going to need another column for a tally. And what I mean by a tally is I'm going to count how many pieces of data fall within the class limits for each class. And finally, I'm also going to need a column for frequency. Now, after we create this group frequency distribution, we would never share this column called tally because this is only going to be used by us to help us figure out what the frequency of each class is going to be. Now that we've established this, what we're going to do now is to create our class limits and then start counting the data that fall within each class limit. Now they tell us to start with the lower class limit of 110. So the first class is going to include all data between 110 and some other upper class limit. But now, this is how we construct the group frequency distribution. The class width communicated is 10. The class width, if you recall, is the distance between consecutive lower class limits of each class. That means if the first class starts at 110, the second class will start 10 units from that. So you add 10 to the lower class limit, and you get the next lower class limit of 120. Notice we haven't figured out what these upper class limits are yet, but we will. But let's finish out the lower class limits. 120, we add another class width to that, we get 130. Add another class width to that, we get 140. Then 150, then 160, then 170, and finally 180. Now, one of the things that you'll also recognize is that for all the data presented here, all the data has a precision of the nearest whole unit of millibecquerels of strontium-90, but the precision is to the nearest whole unit. Therefore, what we're going to do is to create the upper class limits, I want to make sure that my classes don't overlap. Therefore, my first class is going to include all measurements between 110 and one less than the next lower class limit. So 120 is the next lower class limit. So I'm going to subtract 1 unit of precision, one unit, to get 119. And then the next one, 120. The next lower class limit is 130. I subtract 1 from that, and I get 129. And now also notice that my upper class limits of 119 and 129, notice how the difference between those consecutive upper class limits is a class width as well. So I could just simply add 10 from here on out to get the remaining upper class limits. 139, 149, 159, 169, 179, and finally 189. And now that I have the class limits, I can count how many pieces of data fall within each class specified by this lower class limits and these upper class limits for each class. So let's do this. 155 is between 150 and 159. So I'm going to put a little hash mark there. I'm tallying up the data that falls within each class. And then I'm going to cross out that data so I don't accidentally count it again. Let's do the rest. 142 falls within the class between 140 and 149. 149 falls within 140 and 149. 130 falls between 130 and 139. 151 falls between 150 and 159. 163 falls between 160 and 169. 151 falls between 150 and 159. 142 falls between 140 and 149. 156, 133, 138, 161, 128, 144, 172, 137, 151. Now notice 151 falls between 150 and 159, so like a tally, I'm going to use that little indication to group them in groups of 5, just like, like Castaway with Tom Hanks, as he's counting down the days, that he'll eventually leave the island. Now 166, 147, 163. So that concludes the first row of data. Let's finish it out with the last row. 145, 116, 136, 158, 114, 165, 169, 145, 150, another 150, another 150, 158, 151, 145, 152, 140, 170, 129, 188, and finally 156. And now that we have a tally of the data that falls within each class limit, let's write the corresponding frequency. So the first class has a frequency of 2. The second class has a frequency of 2. The third class has a frequency of 5. The fourth frequency has a frequency of 9. The fourth class has a frequency of 9. The class from 150 to 159 has a frequency of 13. The class between 160 and 169 has a frequency of 6. And then we have a frequency of 2 followed by a frequency of 1. Now, if we did this correctly, one way that we could start to at least verify that we have the correct frequency distribution is to add up all of the frequencies. Because notice, we have a number of pieces of data here. We have what? we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 40 pieces of data. So if I add up all my frequencies, I better get a total frequency of 40. And here I go. 2 plus 2 is 4. 4 plus 5 is 9. 9 plus 9 is 18. 18 plus 13 is 31. 31 plus 6 is 37. 37 plus 2 is 39. Plus 1 is 40. So at least we know that we've tallied all of the data. Now we just sort of wonder, I wonder if this is the right grouped frequency distribution. I wonder, if I constructed it correctly. Well, one of the things we could do is we could use Excel to create a group frequency distribution. And the way that we do that is to go within Excel. And now, instead of this worksheet, which just contains a copy of the book problem, I'm going to use this next sheet that's labeled data and click on it. And notice I have all my data here. However, this first entry is just a header that says strontium 90. All the rest of the data from cells 2 all the way down to 41 in the first column labeled A represents the data. And what I'm going to do here is go to just any cell within C and start typing out my upper class boundaries. Now, or upper class limits. My upper class limits start at 119 and then go up by a class width. So I type in the numbers: 119, 129, oops, there we go, 139, 149, 159, 169, 179, and finally 189 for my 8 classes. I just want to make sure they look pretty here because for some reason one of those did that. There we go. So there are all my 8 upper class limits. Now, at this point, I'm going to go to Data and click on the Data Analysis Tool Pack. If you haven't enabled this yet, I would recommend doing so. What you do is go here under File, Options, Add-ins, select the Data Analysis Tool Pack. It might be active already. It may not be. Here's the Data Analysis Tool Pack VBA. That should also be enabled. So I'm going to click Go, make sure everything that I want is checked. You may not see the DDXL add-in. That's fine. But make sure Analysis Tool Pack VBA and Analysis Tool Pack are both checked, and then select OK. And then you should see the Data Analysis Kit when you select the Data tab. When I click on that, what I'm going to choose is this option called histogram, and I'm going to say OK. From here, I'm going to specify my input range. In other words, where is my data? So I'm going to click on this field, and then what I'm going to do is put my cursor here. I'm going to left click, I'm going to hold down, I'm going to select all my data. All 40 pieces of data. And notice how it puts it in there. It says from cells A2 to A41. Then I'm going to click on this field for bin range. And what I'm going to do here is select all my upper class boundaries from cells C2 to C9. Now, down here under output options, I'm going to click on output range. I'm going to put my cursor inside the field, and then I'm just going to select some empty cell like this one. And then the last thing I'm going to do is the following. I'm also going to say chart output. After I've selected all these features, I'm going to click OK. And notice it gives me the group frequency distribution. Now, it doesn't give me the entire classes, the lower and upper class, but it does give me the corresponding frequencies from which we can verify. I wonder if we got the same thing as what's listed here. 22, 5, 9, 13, 6, 2, 1. 22, 5, 9, 13, 6, 2, 1. Good. So it looks like we've got it. The other thing we can notice is this. There is one more column down here listed more. Notice it has a frequency of 0. That means we didn't miss any data. We do in fact have it all tallied by this upper class limits. The other thing I wanted you to notice, which we'll use later, is the histogram, which is coming up.